The distribution of blood cholesterol levels in 14-year-old boys is roughly normal, with a mean of 165 and a standard deviation of 30. So we're saying that we've got a normal and 165 30 squared. And in the first part here, we're looking at the probability that x is more than 170. So that's just straight on the calculator. So interactive, distribution, continuous, normal CDF with a lower of 170 and an upper of infinity. And we know the sigma was 30, and we know that the mu was 165. And I put 170. So 0.4338. What is the probability that a randomly chosen 14-year-old boy has a cholesterol level between 120 and 200? So that's going to be x between 120 and 200. And we could probably just come and edit this one. So change the 170 there to a 120 and change the infinity to a 200. And that should give us the answer, 0.8115. What is the cholesterol level of a 14-year-old boy at the 90th percentile? So what we want is a probability of x being less than some value we don't know, k, being 0.9. And that's going to be an inverse normal. So we're going to go for an inverse normal CDF, tail setting left, 0.9, sigma is 30, mu is 165, and that would give us 203.4. Find the probability that a randomly selected 14-year-old boy has a cholesterol level less than 170 milligrams, given that the cholesterol level is less than 180. So that's the probability of x being less than 170, given that x is less than 180. Now the top of that is just going to boil down to x is less than 170. Remember, it will be less than 170 and less than 180. And that's going to be over the probability that x is less than 180. And we can do that directly on the calculator. So what we can do is go to distribution, continuous, normal CDF, and the lower here is going to be negative infinity. The upper would be 170 with a 30 and a 165. This is invalid syntax. Oh yeah, this is just because it's on top of the fraction. It's okay, we can sort that out with the next step. So continuous, normal CDF. So we've got negative infinity, and this time the upper would be 180. And that's going to be from 30 to 165. And there we go, 0.8188. Now, in this last part, it's proposed that a distribution for a 14-year-old girl could be obtained from the distribution for a 14-year-old boy by multiplying by 0.8 and adding 30. Find the mean and standard deviation. So if we do the mean, 165, multiply that by 0.8 and add 30. And if we do that, we'll find it's 162. But when we do the standard deviation, of course, we don't add the 30. It's just 30 times 0.8, giving us 24.